This is AP Calculus AB, Note 11-2, area between two curves. Our objective today is to find the area between two different functions, which is a little bit different than our last lesson because in 11-1 we were finding the area underneath two curves. Now we're between two curves. Let's start with revisiting an old problem that seems familiar, rate problems. So in example 1, water enters, being a positive word, enters a tank at a rate of 3 gallons per hour and leaves at a rate of that equation per hour. I'm asking for the total change in water between 2 and 4. Normally you won't have any sort of graph. The graph is going to be added on later to talk about the connection between this problem and our note today. Normally what would happen in example 1 is you'd see the words total change in, you'd say, total change in, when you're talking about a rate, means you're going to be doing the definite integral between whatever bounds it gives us, 2 and 4 in this case. You'll say this is going to be between 2 and 4 of the positive rate minus the negative rate and call it a day. You would be correct. This is exactly how you set it up. In fact, you say, yeah, the integral between 2 and 4 of the positive rate, which we know from the word enter, that's the positive rate. So it's going to be 3 minus, and this word leaves is a negative word, meaning we're going to be subtracting this entire equation of t squared minus 6t plus 11. And technically, if I'm being formal, all of this stuff should be multiplied by dt. That is exactly how you do this problem. However, I want to go ahead and connect it to this graph. So notice that I've graphed the t squared minus 6t plus 11 and 3. So 3 is just that horizontal line. What this integral is doing here is it's subtracting one equation from another. What this is doing over here is what we're trying to find is this area right here, because I'm doing the integral between 2 and 4. So between 2 and 4, it's talking about this area here. What this is really saying is do the area of this top function minus the area of the bottom function. What it's really saying is if I find, let me try to make sure I explain this correctly. If I find this area right here and I subtract this area right here, what's left over is this area right here if you do top minus bottom. So that's kind of what I'm trying to get at. Whenever you have the area between two curves, you need to take the integral of the top and you need to subtract the integral of the bottom, and you will always get that formula. So I mean, I'm kind of done with that example. I do want to see what it's all about, though, because while it's nice to say my objective is to find the area between two different functions, I want to be able to show you how to do it without a calculator, which is kind of painful, and how to do it with a calculator, how to use that tool appropriately. So let's finish with example 1. It takes a bit of work, but we can solve it. So with example 1, without a calculator, this is going to be the integral between 2 and 4. And then we have a negative sign that's going to be distributed in here, and then the negative 11 and 3 are going to add to a negative 8. So we're going to say this is a negative t squared plus 6t minus 8. And that is all theoretically multiplied by our dt here. And do we have to pay tax person? No. Okay, the derivative of t is 1, derivative of t is 1. We're good. We don't have to pay tax person, so I'm going to take the antiderivative of each of these pieces one at a time. It's going to be negative t to the power of, okay, we go up from 2 to 3, and then divide down by the 3, plus, okay, and then this is a 6t to the power of, it was a 1, it's going to go up to a power of 2, and then divide down by 2, which is going to simplify. We'll say that turns into a 3. And then we have our negative 8 over here. That's going to turn into a negative 8t. And then this is going to be evaluation bar between 2 and 4. So here we go. We just need to plug in the 4, and then we'll subtract when we plug in the 2. Plug in the 4 gives us a negative 4 to the power of 3 all over 3 plus 3 times 4 to the power of 2 minus 8 times 4. Okay, that's us plugging in the 4. And we're going to subtract what happens when we plug in a 2. It's going to be negative 2 cubed over 3 plus, it's going to be 3 times 2 squared minus 8 times 2. All right, time to simplify. What have we got here? 4 cubed is 64, so it's going to be negative 64 thirds, which is disgusting. I'm sorry, it just is. And then we're going to add, what do we have here? 4 squared is 16. 16 times 3 is 48. So I have 48. And then 4 times 8 is 32, so minus 32. I'm going to go ahead and distribute this negative while I simplify, so hopefully we can make no mistakes here. Negative times a negative is a positive, so it's going to be positive. 2 cubed is 8, so I'm going to have 8/3, another kind of gross fraction, but that's okay. 2 squared is 4, times 3 is 12, and distribute the negative is a negative 12. Distributing the last negative is going to make this one a positive, and 8 times 2 is a 16. What can we simplify here? Negative 12 and 16 adds up to a 4. 48 and negative 32, we can simplify that to a 16. The 16 and a 4 add up to a 20. Let's go ahead and just write the 20 out right now. So 20. And then what about the divided by 3, the fractions? Well, they're like denominators, so I can just add the negative 64 and the 8 to negative 56. So it's negative 56/3 plus 20. I mean, that's the right answer. I just need to get the 20 into like denominators. So let's go ahead and multiply that by 3/3. So the new problem is a negative, I'll do equal sign. This is negative 56/3 plus 20 times 3 is 60, so it's 60/3. And the final answer here is 60 minus 56 is 4, so 4/3 for my final answer. All right, yeah, a bit of work, but it can be done. In example 2, I want to show you how to use a calculator correctly. So let's go ahead and open up our calculator over here. Remember, if you have anything open on your calculator, I'll show you how to do a memory clear. Again, this is going to be a second plus sign, and then 712. And I always like going to the mode and changing this to rounding to 3 decimals automatically for me. All right, so we're ready to go. In this problem, it says that we're just bounded between these two curves. Looks like we intersect at 0 and somewhere else. Typically with these calculator problems, what you're looking to do is to find where your bounds are, because essentially you just need to do integral of top minus bottom. We just don't know the right bound. So I'm looking for, what is this height here? If I can find that height, which is currently a giant question mark, then I have my bounds from here to here. So finding that x-intercept is going to come from finding that intersection, which means we need to graph this. So I'm going to go to my y equals 2 on my calculator. I'm going to type in x to the power of 3, and then minus x to the power of 2. And my second function is just going to be sine of x. And I can kind of guess what my bounds are. If you have no idea, usually the bounds are underneath 10. Usually, I would say very, very commonly, they're underneath 2. They're usually in the 1 to 2 range, if you had to guess, but definitely underneath 10. So I'm going to go ahead and say my window over here is going to go, my x max, I'm going to change it to 2, and my x min, I'm going to change it to 0. And I can actually figure out what the y minimum is going to be. I'm just going to change it to like 0, and my y maximum is probably 1. I'm just going to change it to like 1.5. I'm just going off of the graph, right? 1.5 is right about there, 2 is right about there, 0. Oh, I can't do y minimum of 0. I need to go down a little bit. Let's change the y minimum to like -0.5. So let's change this to -0.5. Okay, we don't have to do zoom 0. We have everything correctly. Zoom 0 would be if we didn't know the y min or the y max. We do know in this case. We're just going to hit graph, and hey, that looks familiar, right? So in this case, I'm going to find the intersection of the blue and the red line on my graphing calculator by hitting second trace to do a calculation of the intersection. That's going to be option 5. I just hit 5 on my calculator, and I think my menu is a little bit different than yours. So just do whatever the prompt tells you. My prompt is telling me what's the left bound of the intersection. I'm just going to say 0. No, that's a bad bound. Let's do left bound of like 0.5. And my right bound, I'm going to say like 2. And it says, okay, that intersection happens over here, and I'm going to mark it on my graph as well. That happens at 1.464. All right, so I have everything set up. Again, my speed sheet definition of the area between two curves is just top minus bottom. If you do bottom minus top, I'll show you what happens. I'll show you later. But it'll be just a negative, and you just be like, oh, just forget the negative, and you're good to go, right? So this is going to be the integral from 0 to 1.464. The top function is this function right here, which is sine of x. it's going to be sine of x, then minus the bottom function, which in this case is x cubed minus x squared. So I do need parentheses. I need to be careful. It's going to be x cubed minus x squared, that entire function. And then that entire thing technically is being multiplied by dx if I'm being formal about it. You'll never lose points for forgetting your dx, but I just like being super formal to make it look cool. All right, so it's going to be, let's get out of here. Let's do math 9, the integral between 0 and that intersection 1.464. And on the inside, I can just do my y equal to, right? So sine of x is my y2, so I can hit alpha trace, go over here to y2 and enter, minus alpha trace my y1, hit enter, and I get my answer, which is 0.791, and I box it. Excellent. All right, that concludes AP Calculus AB's Note 11-2, area between two curves. Thanks for watching.